Hello, everybody. We are live. Welcome, everyone. Today, we're going to be doing an intro to PlanetScale. We're going to be talking about Postgres databases and Vitess databases and high availability setups. We're talking about a bunch of different stuff, but I'm not going to jump quite into it yet. Give some time for people to show up. I see people filing in, which is great. Welcome, everybody. How does it look? How does it sound? So as we're going, we'll start here soon. Like I said, give a little time for people to file in. But if you have questions at any point, just drop them in the comments and I'll take some time. I've also got one of my colleagues in here, Chris, so he might answer some questions on the chat, but I might take some time too to answer some of them live as we're going through stuff. So drop your questions as you have them. Cool. All right. Well, we're going to talk about databases today. And some of you maybe have we've done a couple live streams recently talking about database migration. So how to migrate from a different host onto PlanetScale using dump and restore, logical replication, a couple different techniques. So that's not what we're covering today, or at least not what we're focusing on. We're focusing on just kind of a general overview because we've got a lot of people, especially now with Postgres, that maybe in the past you hadn't considered PlanetScale as an option because you were kind of all in on Postgres. Or maybe you just haven't used it before. So we want to kind of go over some of just the philosophy of what makes a PlanetScale database so reliable and have such good uptime. And then also just going through some of the features of how do you use PlanetScale to identify slow queries and do performance tuning and configuration of your database. So we want to talk about a bunch of that stuff today. So hope everyone's doing good. I've got a bunch of people filing in. Great. All right, so I'm going to go ahead and get started here soon. I've got a few databases that I'm going to use and talk about today. I'm going to put PlanetScale up on the screen here. Let's go to, how do I want to configure this here? Hold on. Give me a moment. There we go. I think this is what I want. Okay. So this is a PlanetScale database. And before we jump in too much, I want to kind of talk a little bit about what we offer at PlanetScale. Again, some of you are longtime users and you're used to this, and which is great. You hang out, ask questions. But for those of you that are new to this, so for a long time, PlanetScale, our main focus was on Vitess and MySQL databases. So MySQL, of course, arguably the world's most popular relational database. A lot of people like to use that. But when you would create a MySQL database on PlanetScale, what you actually are getting is a Vitess with MySQL database. And Vitess is an additional piece of software that runs and operates along with MySQL to add a bunch of capabilities. So high availability features and observability features to monitor the health of your databases. And by default, we usually run things in an HA setup. So you have a primary and two replicas, and so it can handle the switchovers and failovers there. We use it to do schema migrations. You can use it to do sharded databases, so really, really large scale, hundreds of terabytes kind of size databases. So that's what we had and kind of was our main offering for a long time. And then just recently, a couple months ago, we announced support for Postgres, which we're in early access on. And if you don't have access to that yet, definitely reach out to us. You can sign up on our website or you can email postgres@planetscale.com. We can get you in. But that's what I want to start by talking about is Postgres databases. And then we'll kind of go and look at some Vitess database stuff as well. So let's look at if you sign up for PlanetScale, you create a new account. The first thing you're probably going to want to do is create a database. So if you come in and do a create new database in here, this is what you're presented with, right? So we're going to create a database name. You pick your region. So we have support for both AWS and a couple of GCP regions as well. AWS is definitely our more popular one, but a lot of people use Google Cloud, right, you generally want to have your database near all of your other infrastructure. So if your app servers, if you're all in on Google Cloud, then you want to make sure your PlanetScale database is near those in the same region, ideally, right? Same with AWS. So you pick, which AWS region you want. And then this is kind of the key decision here is, are you wanting a Vitess and MySQL powered database, or are you wanting a Postgres powered database? And there isn't like a right or wrong answer, right? Like Postgres is very popular these days, but MySQL has some advantages over Postgres, especially when combined with Vitess for sharding and scalability. So it just depends on like your needs when it comes to something like this. So Vitess, Postgres, we'll do a Postgres database for the time being. And I have a couple, like I said, we're going to bounce around and look at. And then another interesting thing that we do is, a lot of times on, both PlanetScale and a lot of other providers, when you go and create a new like managed database instance, almost always that is backed by EBS in AWS or some kind of network attached storage. In other words, you're getting your compute, your server with a certain amount of, CPU and RAM and all this kind of stuff. But your storage, where your data actually lives on disk, is on some form of network attached storage, right? So every time you read and write, you're going over the network to hit those disks. And there's also generally limitations for how many IOPS you can get and throughput and latency. And then you can often pay more to get better performance, but there's some limitations with that. So sometimes it's great because that gives you more elasticity. We can do auto scaling for you, where we auto scale your disk up and down based on like your usage. So there's some things that are very nice and convenient about that. But PlanetScale Metal is our higher IO performance option. So this is still in AWS and GCP. Some people hear the term Metal and they think, oh, it's your own custom data center. This is still in AWS, GCP, near your other infrastructure. But we're running on certain kinds of instances that have locally attached disks. So you can come down and see we have a bunch of options both on AArch, so like ARM and x86 64. And what you do is you come in and you pick, here's how many resources I need compute-wise, and then there's different options for what size disk goes along with that. And what you're getting is a fixed size disk, but incredibly high performance because it's a local disk, right, on the same rack. There's no paying for extra IOPS, basically as much throughput as you could need with a local disk. So really, really good performance. And this is something that's not very common. You don't really see databases running on this typically, but because of the way we do replication and high availability and monitoring of your cluster, we can use these and get really, really good performance and also incredible reliability. So this is what a lot of people use if they have real, performance demands, right? And you look, another cool thing to keep in mind too, some people will look at these prices and kind of wonder, why does it cost this much for 4 CPUs and 32 gigs of RAM? Whenever you're selecting one of these databases, it's always actually ×3 because we give you a primary server like you see over here with those specs, but then we also give you 2 read replicas that are replicating from your primary, and you can send select queries to those, and they're used for failover to keep your database highly available in case there's any server issues. So you're actually getting 3 of those servers for that price, right? So like in total, you're actually paying for 12 CPUs and 96 gigabytes of RAM, plus in this case, that attached storage there. So, okay, there's a bunch of people that have come in since we started. So I'm just gonna say hi and welcome to everybody. And I will also point out and remind you, if you have questions as I'm going through anything, we're just kind of doing intro to PlanetScale, talking about creating databases, doing performance optimizations, Postgres, MySQL, the test stuff. We'll talk about a bunch of things today. But drop your questions as you have them. I'm in here, and also some of my colleagues are in here too that can answer questions on chat, and I might pull up some of your questions on the screen and we can talk about them. And let's see, I'm just going to pull this up because this comment rocks. Yes, PlanetScale does rock, you're right. But I can, pull up your questions, we can put them on the screen and we can chat about them. So feel free, drop whatever you're thinking, whatever questions you want answered. So let's go back to, this is the create database page. And what I'm going to do for this example, we're just going to use EBS. Again, pros and cons. It's not like there's one right answer, but I'm just going to create a small database for an example. We'll hit create here. And then it takes a little bit of time to spin this up, right, to get the infrastructure going. But if you come back here in a minute or two, it will be ready to go, ready for us to start doing stuff with. And we will come back to that, but there's a few other things I want to show first. So what I have, and I prepped this ahead of time so that we had something interesting to look at. So I also have this database over here, which this is one of our metal databases. Let me see. Kind of looks a little bit small to me on the screen. I'll zoom in a little bit more here. And this is what you see, once the database is all created and everything, you have your architecture diagram. And what you are typically going to see, this is a Postgres one, but you have a primary and 2 replica databases. So this is like what I was talking about before. This one is an M160, so each of these has 2 CPUs and 16 gigs of RAM. And so right now, I'm actually sending all of my queries to my primary, but I could send some to replicas if I wanted to. And the reason for this is several, right? One is just generally, if you want a highly available database, you never want to be relying on a single node. In fact, this applies to a lot more than just databases. Your web apps, like any kind of infrastructure you're doing in the cloud, you never want to just have a single point of failure, right? Because something happens to go wrong with that AWS availability zone, or that particular node dies, or the power goes out on that rack, whatever it is. Then you're down, right? And it could take a long time to spin up unless you've planned ahead for this. And so what we do is whatever region you select, in this case, it was US East 1, we always give you 3 nodes across availability zones. So if something happened in AWS and all of a sudden this node became unavailable, we're replicating your data to the other 2 nodes. And we have our orchestration layer detects when there's problems, and it will automatically make a switch and say, okay, promote this replica up to being your primary now. And then we'll create a new replica for you, and we'll handle all of those. What is really a complex thing behind the scenes, we just handle those things for you. Yeah. So, oh yeah, someone asks about having Postgres experience at what historically was mostly a MySQL company. So yeah, we historically are a big MySQL company. That's true. We have quite a few people actually who have, even prior to launching Postgres, a lot of experience managing Postgres databases. So it's not at all that we didn't have experience with it. It was just that our focus was on MySQL. So yeah, it's been actually really cool to be able to kind of meld those expertises, and now we get to do both at the same time. It's really cool. Yeah. So let's see, where were we? We were talking about primary replicas. Let's look here. What other stuff I wanted to look at on this main page? Yeah, so this is just your overview, right? You get a sense of how much storage you're using, your bandwidth usage, your IOPS. So this is one of the big advantages of Metal, right? This relatively small compute node, because I'm on Metal, has up to 100,000 IOPS, or it has that many available to do reads and writes to the disk. Where if you wanted that using EBS in Amazon, you would be paying thousands of dollars a month just for that disk, probably an IO2 disk or something like that. And even then, I don't even know if it goes up that high. So really, really good IO performance from these nodes and from these disks. So let's see. Again, reminder, ask questions if you want to drop things in there. Yeah, and someone asked too about does it want to PlanetScale? Does it make us want to host more of our stuff on Postgres instead of MySQL? Well, we'll get into talking some about that. I think one of the things that I actually really like about the fact that we support both now is we can try to have really unbiased opinions about the pros and cons of each. I mentioned earlier in the call, Postgres is very, very popular these days. But the reality is there are some things that MySQL plus Vitess are better at than Postgres, and there's some things that Postgres is better at than MySQL. So even though they're very similar in a lot of people's minds, it's okay, they both do the same thing, so I'll just pick the more popular one. There are actual real trade-offs that you can say, well, MySQL makes more sense in this case. It's easier to manage in certain ways. A good example of that is the way Postgres writes table data to disk. And you need to do occasional vacuums to reclaim space in your indexes and in your tables. You actually have to pay a lot more attention to basically cleaning up like unused rows, dead tuples in your database, whereas MySQL, you might have to worry about that occasionally, but it handles a lot more of that for you because of the way it does clustered indexes. So it's not a one is just better than the other. It's all trade-offs, which is cool. Let's see. A question here. Why having physical memory in the node that DB is running is not that common, cost inefficient. So I'm not quite sure what this question is talking about. Oh, maybe when you say memory, maybe what you mean is the disk that where we're saving the data to. And yeah, because like I mentioned, right, we have those two options, using a network attached storage or using local NVMe disks that are very fast. So one of the reasons why us doing that is good is because of the way that we do replication. By default, we always want to provide a highly available database. So we're always replicating your data across multiple nodes. And that's one of the reasons why we can do it really fast and also with really, really great durability guarantees, because your data is always copied several ways. Let's see. Oh, okay. This is a good question. Yeah. Maybe I can actually come back to this when we get to talking about Vitess, because that has some more features for this. Again, this is where those pros and cons come in. If you're in, so the question here basically is you're in one region like US East 1, very popular one. And yeah, if most of your customers are near that in the US, your latency to your app servers, which hopefully are also in the same region, and then to your database are all very close. So you're going to have good performance. But yeah, as you might expect, you start to go other places around the world and latency is going to get worse. And this isn't just because of the database, because you can have an extremely fast metal database, but the latency of just traversing around the world takes time, right? Going halfway across the world. And especially if loading your web page requires quite a few round trips, right? That could actually be really slow. So the solution there may be some things with the database. And one of the things I brought up Vitess is we give you the ability to really easily spin up read-only regions, read-only replicas in other data centers around the world. So that at least for read traffic, it can be a lot faster and we auto route to the nearest one. But there's also some things that are just going to be hard, right? Because like no matter, even if you add that, there's still where are your app servers deployed to and thinking about those round trip times. So yeah, that just takes some careful engineering. All right, let's get back to PlanetScale. Love the questions, so keep them coming as we go here. A few things to talk about. So let's look at, while we're here on this database, I am kind of throwing some fake workload at this while we're talking. So let's look at a few pages just to see like how do you monitor these databases. So this page here, I've shown on some other live streams before. This is the metrics page. And if you kind of want to see what's going on with my database, am I over provisioned? Like, do I have more resources than I need? Am I under provisioned? Or maybe you notice like there's an unexpected performance problem from your app side connecting to your database. This would be a good first place to go look because it gives you a lot of insights into just what's going on with like your resources that you have. So like here, the first graph is your CPU and memory. And hopefully normally you wouldn't see this much crazy variance in the course of 3 hours, but I kind of made it spiky on purpose with my example workload. You can see how many IOPS you're using. You can expand and close these graphs here, your disk space, things like that. Some of these are not, for what I'm doing right at this moment, not as useful. So this is showing our connection information with PS Bouncer. So this is essentially your connection pooling layer, which you probably would be using in production if you have lots of app servers or runners that are making short-lived connections. You would probably be using PS Bouncer for those, but I'm not really using those right now. But a lot of other things like we'll talk about backup soon, which require, if you do point-in-time recovery, you're going to be using the write-ahead log, and you need the write-ahead log in general for logging. So you can see like stats on the archival rate for these and whether it's failing or succeeding. And some other interesting stuff like how many connections are being made on your database over time and what those connections are composed of. your memory usage. So we show memory up on the top, but this is a more detailed breakdown of like how much is your active Postgres cache versus inactive like OS cache, things like that, to give you a really clear picture. So right now, other than the fact that just CPU is spiky, and that's on purpose because I'm purposely sending more and less QPS to this database, things seem generally fine. Other than the fact that I hit 100% CPU or near it a couple times, which generally you don't like to see, right? If you're hitting 100% CPU, that probably means you need to increase the size of your database. So let me look over here. Okay. So let's look at a couple of other things. The more interesting thing that I want to talk about that kind of involves monitoring your database is insights. So this page is great, right, for certain kinds of problems that you want to solve. But if you're going beyond just, okay, how much CPU am I using and how much RAM and all that, and you want to start to actually drill into, okay, I have a certain workload running on my database, my queries, and I've selected which indexes I want for those queries. Maybe you're writing those queries by hand. I know in a lot of cases you're using some kind of ORM like Drizzle or something that's writing the SQL for you. But this is where you'd go to look at like query performance, right? And to drill into what are my slow queries, what indexes do I need to add, things like that. So I've pulled up the insights page and I've told it, let's just look at the past 3 hours because that's where most of my example data is. And you get a nice overview of just, your P50, P95, P99. So looking at your different percentiles of how slow your queries are. And this is one that's kind of cool too, because like we can look at, even P99, which means whatever this time is, 99% of my queries are running slower than this and 1% are running faster. So my P99, I look here and even this like spike, that's only 3.8 milliseconds, 4.5 milliseconds. So that looks like pretty good. And even my P99.9 gets a little worse, but this is only a very, very small percentage of my queries. So we've got 41 milliseconds, 28 milliseconds. We recently added max, where here you can look at, and I can see, wow, actually, even though my P99 looks pretty good, occasionally I'm getting queries that are taking, 1.8 seconds to run, 1.1 seconds to run, right? So those might be ones you're interested in. That could have been just because those were those times where I was maxing out my CPU, right? So I was not sizing my database correctly. But those could be things that you want to drill in and look at. So what you can do is, in addition to just the high-level overview, we actually give you a per query breakdown of the queries running on your database. So we can see here, underneath that, I've got a big table where I even have like the spark lines for, so this particular query, right, I can sort by like the percent of time that it's run. So these are my queries that are kind of run the most often. And we can see that actually a lot of these stats aren't too bad other than the P99 latency. And again, a lot of those high numbers are just from, there was a period where I maxed out my CPU. So that probably, either means I need to upgrade my cluster or I need to do some performance optimization so that next time I get a traffic spike like that, I don't have those performance issues, right? But a way that you could like solve these problems is you go in. In fact, what I'm going to do instead is I'm going to sort by P99 latency. And in fact, this right here very quickly reveals a query that went really slow, right? Like this very obviously stands out. These spark lines, we can see like, hey, this query basically ran one time over the past 3 hours. So it's not run frequently, but it took a second to run. And maybe you expect that. Maybe this is like a periodic cron job or something that runs once a day, but maybe this is like, wow, that's bad. Let's go fix this. And we even have over here a little indicator that like something is unexpected with this query. In fact, we highlight over it and we'll see this when I click on it, but it says no indexes are being used on this query. So we identify the fact that like, hey, performance is bad here. You're not using indexes. And you can actually go and click on queries. This is a very simple select query. And the graph here is kind of boring because it only ran one time. But we can see like we get this warning right here in the UI. No indexes are being used. Adding an index may improve performance. In this case, I purposely did a silly, what do you call it? Like select query to kind of show this. But let's say a different one of my queries like this one actually runs a lot but it's just one of the slower queries in my database. And we can go down and look. And in fact, for this one, it is using indexes 100% of the time. I have 2 different indexes that it uses 100% of the time. It's possible that I could add more indexes or different kinds of indexes to get it to perform better. But we can see, like, just for this query, what are the performance characteristics, what indexes are it's using, things like that. Okay, cool. Yeah, someone asked about pricing. It looks like we already answered it in the chat, which is great. But yes, so pricing will be a little bit different between MySQL and Postgres. There will be more information about that coming out in the future. Yeah, and you can also see pricing info if you're in the early access and can see things when you create your databases and in the UI. So this is regular metrics, which are very useful for certain situations, but combined with tools like this are super powerful. We even do things like you can see here, back at that time from a couple hours ago, when I had that spike to like 100% CPU, it's like telling me, actually, wait, maybe that was, yeah. So it's telling me that there was an anomaly detected. I can scroll down here. Between this period of time, the percentage of slow running queries increased. And since I've already looked around at metrics, I know, oh, that's because I shot a bunch of query load to my database. But as a DBA, you might say, okay, now I need to decide, does this mean I need to upsize my database? Does this mean I'm just going to go in and do some performance optimizations? Does this mean that I need to go make my app more efficient? Maybe it's doing a bunch of like dumb N+1s or something, and I need to make that more efficient, and that will alleviate pressure on my database. But we give you all the tools to investigate it, and then you can figure out what's the ideal way to go address this. But I get this anomaly, and the cool thing too is if you have an area that you want to look at, like I can drill in on this time frame here and zoom in and see what was going on during that time. What were these slow queries that were running when there was a spike and all of that. And there's a bunch of different graphs you can look at. You can look at your queries per second, how many row reads you're doing, how many row writes you're doing, and then also get a summary of errors. So this can be nice too if, like here we can see there's a number of things: no transaction progress, could not serialize due to a concurrent update. So I'm getting a handful of errors, and in reality, you wouldn't ideally, during good operations, you wouldn't want to see a bunch of errors. So this is a great place to go in and see like, hey, there was a spike of errors here. Again, maybe that's because my server was simply resource exhausted. And then I can see like how many times these different errors happened in these time frames and all that. So really, really, really powerful tools for drilling in on what are the performance problems, how do I solve for slow queries. Yeah. So let's see here. A few other things I'll talk about with Postgres, and then I also want to talk a little bit about Vitess because there's some interesting differences. And if you're coming to PlanetScale, you might wonder like which one of these is the better choice. So we'll talk about that a little bit. But let's talk about backups before we go over there. So this is something that it works a little bit different than how it does in the MySQL world, if you're used to or coming from that. So we do default backups. I believe it's once every 12 hours, and we retain them for 2 days. Although this database I just created yesterday. So we can see there's only 2 over that 2-day window so far. And so you can create new backups at will, right? So if you're just like, hey, maybe I'm about to make some big schema change and I want to take a backup, sort of like a snapshot of what my database looked like before that, you can select on my main database, let's create a snapshot, how long you want to retain it for, and then you create that database backup. We handle that for you, and then we'll show it here in this menu to be able to restore to. But the other cool thing is because we're also archiving your write-ahead logs, and basically we retain your write-ahead logs as far back as whatever your oldest backup is. That means you can do a point-in-time recovery between the present moment or a couple minutes ago and whatever your oldest backup is. So in this case, 17 hours ago is my oldest backup. I could do a precise point in time recovery and say, let's recover to Monday at 8:34 a.m., right? And then I could hit restore backup, and it would create a new branch that is restored. So a new branch, as in like essentially a new database server, a new database infrastructure, but restored exactly to that timestamp. And maybe I'm doing it because I need to investigate something. Maybe, one of the use cases for this is perhaps you mistakenly like got rid of some data, a couple hours ago, and you're like, oh shoot, why are these rows missing from my database? You could go restore back to a time when you knew those existed, get that data out, extract it, and bring that into like your production database, right? So point in time recovery stuff is really powerful. With logs, all of these kinds of things. So we give you, it's a Postgres database that's highly available. That's one of our our big goals, is we want to make sure that if we're giving you a Postgres database, it's very reliable, has good uptime characteristics. And that's a part of this whole, by default, giving you a primary and 2 replicas and detecting when things, if there's an issue with an availability zone, and then doing a switch over. And then also on top of that, giving you all the tools you need to monitor, do performance analysis, try to make your queries faster so that you can take those resources and utilize them as well as possible, right? Not be wasteful of your CPU and your memory and stuff. All right. So reminder, if you're watching and you have questions, drop them in the chat. We've answered a couple of good questions so far. And then pretty soon here, I want to talk a little bit about Vitess, and we'll talk about some sharding stuff as well. Let's see, I'm going to go back to, okay, this is that database I created earlier, probably finished a long time ago, but it's ready now. When you first create a database and you want to connect to it, you're generally just going to go over here and hit connect. We also have a page where you can go manage your roles over here and create roles. You can kind of use either technique. But just so that you're aware, right, when you're creating your initial connection strings, we have a nice UI for going through and either doing a default role or a user-defined role, and you can be very specific about what permissions you want to give each one of your roles that you create. You create it, you save those usernames and passwords, and then start connecting and maybe doing a migration, whatever you're going to do. Let's see, another question from Alex. Walls stored from time of the oldest backup. Yes. So yeah, you may have just missed that. From whatever your oldest backup is, which by default was essentially 2 days, as long as your database has been around that long. But you can sort of forcefully create backups that you hold on to longer. Like I showed in that UI, you could create one that you keep for a month and do point in time restores with that as well. All right. So let's talk a little bit about Vitess as well. So here I have another database. Again, this is all in PlanetScale. We'll go back to this is my, I'll refresh now. I have a third database. So this is just an organization that I have, SpeedyDB, and I have a couple databases in here. So this one is the one we were just looking at for a while. This is that new one that I created when we first started the call. And then this is actually a Vitess database instead of PlanetScale, or sorry, instead of Postgres, but it's all here in my PlanetScale UI. So clicking in here, I'll actually go back to just this tab that I had. So it looks very similar, right? We try to, as best we can, make the UI feel very consistent so that the usability is consistent between these two. But because under the hood, there's slightly different technologies, we present some things in a little bit of a different way. So here, one of the things that is a little bit different with Vitess is you're getting your primary and your 2 replicas, but you're also getting, in Vitess, it's called a VT gate, but this is basically a proxy layer that handles connection pooling and query buffering when there's failovers and these kinds of things. So you see that in your architecture diagram, and you can actually look at resource usage for this, and you can even scale this up and down independently. And then you have your primary and your 2 replicas, right? So this is a pretty small database over here. Let me go back real quick to Postgres, because what I didn't show, and I want to compare and contrast that, is over here in your cluster configuration in Postgres, we give you a bunch of options to tune parameters, right? So this is where you can set your max connections or how much cache you're using. You can see a history of your changes, enable extensions, these kind of things. But this is where you also do things like resizing your database. So even with Metal, with fixed size disks, whether it's Postgres or Vitess, you can do resizes to bigger instance types with no downtime. So we handle behind the scenes all of the copying of data to the new servers and replacing the old nodes with the new nodes. So you can do all this, no downtime. But it looks a little bit different. Now I'm back to the Vitess database. It looks a little bit different in Vitess land. So looking at the cluster config here, what we see is this is a database I'd already set up and done some stuff before. A little bit different of a UI. And this is because with Vitess, you can have a single database, but then you can have multiple what are called key spaces. And those are like your logical individual MySQL databases. And so here I have two. I have game, and this was the default one when I just created my new database when I was doing this yesterday to prep for this. Let's change this graph here. And I can see here's the cluster size. I could change this to a bigger cluster size. I could add more replicas. I could save these changes, resize all with no downtime. Look at some different settings over here. But I also have this chat key space. And this is where we get into a little bit of database sharding. So if you don't know, database sharding essentially is what you do when you start to kind of grow your data size and your queries per second and all this kind of stuff beyond the point where a single server can even handle it, right? Like we have options to go up to very, very large server sizes with, like looking down here, 64 CPUs and half a terabyte of RAM and huge amounts of metal storage and all this. But there's some organizations that have, hundreds of terabytes of data, and you don't even have to wait till you get that big to shard. You can shard at a couple of terabytes of data, right? Especially if you have really high traffic volumes. So that's what this other key space is over here. We can see it kind of looks green when we look at this, but this indicates that it's a sharded database. And I'll actually show you what it looks like. I'm not going to actually create a new one right now, but I'll just show you the UI. So I could create a new key space, and I could call this other sharded database. And I could set my resource size. I'll just keep it on something small for now. Each one by default already comes with the 2 replicas, but then I might say, I want this to have 8 shards. So what this is going to do is your database, it's actually going to create 8 different instances, each that have a primary and 2 replicas themselves. And then the power of the cool tech behind Vitess will make that all look to your web apps in Rails or Laravel or whatever you're using. It looks just like a regular single MySQL database server that you can do select queries on, updates, inserts. But Vitess, as well as a little bit of config that you do here in the UI, knows and controls which rows behind the scenes get sent to which database servers, which servers store which ranges of IDs, and all of this kind of stuff. So really, really cool. I'm not going to do like a deep dive into Vitess today, but it's incredible power for scaling up your database. And that's one of the things I love about PlanetScale is you can start with a small database. You can start with a database that's a gigabyte, right? If you're early on in your product or whatever. And as you grow and grow into 50 gigs and 100 gigs, and then you hit the terabyte, and then you hit multiple terabytes, like you don't have to like, oh, well, I need to move off PlanetScale because now I've outgrown it. It's meant for handling the world's biggest workloads as well. Okay, there's a few questions in here. Let's see. Someone's asking about Project Neki. Yeah, so I'll point out too, we have Neki, which is a sharded Postgres that we are working on right now. So currently, like in our UI, you can't do this sharding on a Postgres database, but that will be coming soon. So stay tuned for that. Let me see a couple of, oh yeah, we've linked a blog post in the chat there. Show you operations with those creds. Oh, okay. So you're asking about essentially permissions, and I'm guessing this is for Postgres because this was back when we were talking about Postgres connections. So we give you, I do not believe we give full root privileges on Postgres, but you can assume the Postgres role, which gives you the ability to do a lot of things like enabling extensions and that kind of stuff. So you hopefully get all the control you need for kind of that, all of that administration that you want to do of your database. And then another question, where do we define the shard configs? I will show that in a second, and I'm guessing you're talking about Vitess here. Let's see. And then someone is asking about, for MySQL / Vitess databases, you have around 800 gigabytes of data. with PlanetScale import, can I import the entire thing without failing? So you can use our import tool for that. And yeah, imports between Postgres and MySQL, we have a little bit different ways of doing those two things. With PlanetScale, we actually, or with Vitess, we have an import specific tool. One of the things to be careful about with the import tool is just, even though if you're going from an existing MySQL database, assuming that's what you're doing, if you're going from MySQL to Vitess, those are compatible because they're both using MySQL, but sometimes even little config differences or version differences between the two can cause some like incompatibilities or issues. So this tool you can import your database with that, but if you do encounter anything that seems like an incompatibility issue or something, definitely reach out to our support. And that's just the nature of databases. Sometimes they're complicated, but we've seen a lot of these different kinds of things come up. So if you're stuck, talk to us. We'll get you helped out. Yeah, okay, and so this is a good question too. So is there an option to specify how the sharding happens? For example, in a multi-tenant situation, you might want to store a single tenant's data on a single shard for speed. Yes, exactly. So that is about where I was going to get to. That's a good question, Daniel. Where was I? Oh, so this is still the create new shard UI. I don't want to create a new one right now because I already have an example one here. So this is my existing unsharded database, and this is my chat one, which is very simple. It's just very small. It's only 2 shards, but the same exact principles apply whether you're talking about 2 tiny shards, which is really, you normally would not shard with 2 PS10s, right? If you're sharding, that means you have really big scale, you have many terabytes of data, so you'd be doing much larger nodes and multiple shards. But all the same stuff in terms of how you configure it applies. So the way that I specify, okay, now that I have these shards, how do I want the sharding to occur is over in this tab called V schema. So you see V on some things when you're with Vitess databases. So the V is short for Vitess. So over here in my unsharded database, my V schema, I had specified that these are all my tables. It's a small database, just a couple tables simulating a spaceship game. And I have specified that these are unsharded, right? So this is an unsharded key space, and I'm just explicitly saying I have all these tables and they're not sharded. So treat these like it's a normal MySQL database. But then over here, this is something that I set up yesterday. This, using your V schema, and there's documentation for like the different kinds of options and parameters you can put in here, but it's basically a JSON file. And this is how you specify what I want sharded here. So what I've done, which might be a little atypical, but it's kind of nice for the sake of example, is this 2 shards handles 1 table, particularly my message table. And you might imagine that kind of would make sense because a lot of the other tables in my game might only have, thousands, tens of thousands, or maybe hundreds of thousands of rows. But then if I have some kind of direct message support in my, live game that people can play with each other online, that table could grow to like millions or billions of rows if lots of people are messaging each other. So this one I'm choosing to shard. And so I specify a V index, a Vindex, and I'm saying this is of type hash. So basically what that means is I'm going to take any new rows that I get. Someone says insert this row into the message table. I'm going to get it, and I'm going to perform a hash on where I specify down here, the ID or the from ID. So this is the ID of the person that has sent the message. So I perform a hash on that. It's going to produce some hash. And then that hash is what is going to determine which one of the shards it's going to go to. So this gives you the control, like you were talking about, if you want to have control over, well, I want to make sure that like if, the same player sends another player 10 messages, I want to make sure all of those messages end up on the same shard for performance reasons so that locality-wise, they're close to each other. That's the kind of stuff you control in your V schema. And this is a pretty simple one because it's just 1 table. We're doing a hash ID, which is very common, but you have a lot of control. Like you can make it very simple. Just, hey, hash these columns, shard by this column, go to the table. But you can also do a lot of custom stuff with this beyond just hashing. You can have it use lookup tables to figure out where to send your queries to, or where to send your rows to, a bunch of different stuff. But this is where you specify it. And here it's as easy as you go in, you make your edits. In this case, I'm just saving here, but you also can, in our Vitess product, you can do deploy requests, which is a way to essentially do safe data migration, schema migrations, excuse me, without downtime and kind of doing it in a safe way. And you can also do your V schema changes with deploy requests rather than just directly doing edits like this. And if you actually have a database in production, that's going to be the safer way to do it, is using deploy requests. So in this case, I'm not going to actually walk through and redo all these steps live, but that's essentially what I did when I was setting up this example yesterday, I think it was, is I created my database, and then I created a sharded version. I specified my V schema, what things I want to be sharded. And then I ran a script that just loaded a bunch of data into here. And so I have queries running on this, right? We can see that for my unsharded version, this is where my user table is and some of these other tables. So there are, if I look at like whatever the past hour, right, there's some reads and writes, there's some queries happening. I'm not using a lot of IOPS because most of this just fits in RAM. This is a very small database. But you can also go and look at the metrics for your shards. So this is my sharded key space. It's got like these two green sharding layers. And I click on that and I can say, I want to look at, these are the two shards and those represent what key ranges it's supporting. So I'm going to look at my first shard and I'll look at the primary and make sure, you know, resource usage is good. We could go do that for my other shard. And the other thing we could do too is, let's go, I'm actually going to need to check a command here. I'm going to stop the traffic on this just so I can check this. Okay, so that's what we'll do. For Vitess databases, you can enable console access right here in your UI. So I can say select count from my, I think it's called the message table. So small data set. I only have 10,000 rows in this. But one of the things that you can do that's pretty cool is you can actually specify which shard you want to use. So I can say use chat, which was the key space name, and then the -80 shard. And then in this shard, I can count how many messages, and I can see, okay, 5,200 of the messages ended up on the first shard. And then my other shard was labeled this. And so 4,700 of the messages ended up on the other shard. So this is how, when I loaded the data, Vitess for me, I told it, hey, hash these IDs. This is how you divide up the data. And that's how the division ended up happening based on those hashes, right? So approximately, hashes are going to spread all your data out evenly, assuming you're hashing on like a unique ID column. But of course, it's not going to be exactly even. So here I've got slightly more data on one shard than the other. Yeah. So we also, like, along with giving you the ability to set up a sharded database easily and configure it and specify, you know, your V schema. I won't have time to demo this today, but we also have this idea of workflows, which comes from Vitess, which this gives you the really good ability to, for example, if you had a database in PlanetScale that was on Vitess that was not sharded, and then you realized, like, one of these tables is growing really big, or my whole database is growing big, I need to shard it. This gives you the ability to essentially move data from, for example, unsharded key space to a sharded key space, and then have your traffic get switched over to the sharded database without downtime, right? And kind of walking you through all those steps and handling the data migration for you. This can also be used for other purposes as well, but it gives you the ability to kind of move data around from uncharted to sharded and manage the complexity of that. And then also here we have insights, just like we had on the other one, right, where we can look at your query performance, your max queries, your slow queries, just like in Postgres, right, drill in on individual query performance. The metrics looks a little bit different, like I was showing before. So the way you get to your CPU usage and your IOPS and stuff is by using your architecture diagram and going through, selecting which node, which shard, and then kind of looking at your metrics over here in the side panel. So we also have backups. Backups are a little bit different because the way that Vitess actually does support point-in-time recovery, it's just not something we've productized in our application. So here in the Vitess world, when you do backups, or we still do the automated backups that are maintained for 2 days, but you're basically just restoring from these snapshot backups if that's something that you're interested in doing. Oh, this is a good question. Going back to when we were talking about workflows, Daniel asks, would the workflows be necessary to upgrade the cluster, or does that happen automatically? So you don't need a workflow if you are just changing the size of the resources in your database. That's only if you're like actually moving from unsharded to sharded, because you have to move that data from a single server to start being spread out across many servers that follow the sharding rules. But if you are just upgrading the resources, like let's do just a simple upgrade, I'll upgrade this to a PS80, right? Let's say I'm getting a lot more traffic and I want more RAM and more CPU resources. I'm going to save these changes. Which database? Oh, this is my game database. Yeah. So I've saved these. And then I believe, yeah, so now it indicates my cluster is currently being resized, and additional changes can be made once it's done. So this resize happens with no downtime. I'm not sure if it'll show up quite in the dashboard yet. Let's go and look over here. Yeah, so it shows me that it's resizing these nodes right now. You can even kind of view when it started and what the progress is on all that. So that's a no downtime. Don't need workflows for that. And that's a very good question. Cool. So hopefully this helped. Hopefully this was a nice intro. You learned a lot about PlanetScale. If there's people on the call, if this is like your first time using PlanetScale, or if you just recently got access to Postgres, yeah, use it, try it out. If you have questions, like reach out to us. That's what we're here for. We're happy to help. We're probably going to keep doing live streams like this, maybe every other week. Probably the next one that we do will be one that talks about migrations. So if you're interested in like, hey, I have data on a, maybe you're self-hosted, whatever it is, I have data in Postgres, or maybe it's in MySQL somewhere, and I want to learn more about how to get that data into PlanetScale and start testing it and using it and doing switchovers. We'll be talking more about that soon. But I'll also, in the meantime, because that might be a little bit away, let's actually go back over here. So one of the things you'll notice when you create a new database, and if we detect you don't have any tables on it yet, so this is that new one I created at the beginning, we give you some direct links to resources for you to go through to do that migration. So one thing we link to is a couple pages on our docs. This is just our overview of kind of general principles for doing imports. We have a couple of specific guides over here on the sidebar where we have some general instructions for like, hey, here's how you would do it using dump and restore for wall streaming. We have a few provider specific guides that give you a little more detailed instructions, because each provider, the settings you have to configure is a little bit different. And then finally, and this is something that I guess it's not here. Let's go to like this guide. We also have some scripts that we support, this GitHub repository called migration scripts. And in here, depends on what you want to do. We have a few options for both migrating into MySQL and migrating into a Postgres database. But let's say you're on Postgres and you want to migrate to PlanetScale Postgres, you would use these scripts here. And basically this helps. It's a little bit more sophisticated, gives you more options than just the guides do. But if you want to kind of have some of these steps be automated, these scripts are great. We've had a number of customers use them and are very happy. And then, but if you want a little bit more manual control, kind of want to know each step of what's happening, then you can use the guides that we have over here. And let's see. Yeah, there's approach to. Oh, okay, interesting. So someone's asking approach to CI/CD would be interesting. I'm thinking maybe you're talking about maybe a subject for a future live stream. And yeah, that would be cool. We do have an API where, especially with the Vitess product, with the branching and DRs, you can integrate that very nicely with your GitHub workflows, your GitHub actions. There's a lot of cool stuff there. And then someone asks, is every Postgres extension supported? Oh, okay. So it looks like Chris linked the doc, but yeah, there is a doc for that, our extensions page. And so here we list out which ones we support. And then the other thing too is we of course always want to be kind of monitoring with our customers, like we have the things that we do support, but what are additional extensions that customers are interested in? And we don't just by default let you do anything, partly for security reasons. We don't want, for the sake of security, people to just be able to arbitrarily install and run an extension. So we manage which ones are allowed, but as we get feedback from customers, hey, I rely heavily on this extension. And if we get a lot of customers requesting it, then we will go and build support for that extension too. But already, even just since we started with Postgres, we've added support for a bunch of things like PG Squeeze. I believe PG Partman was recently. So, we're continuing to kind of see what we need and what our customers need, and then add those things. All right. Let's scroll down. So yeah, I think a lot of good questions. I think we're almost at time. It's meant to be an hour stream. Hope we got all your questions answered. If you have any other questions, go to our support, so planetscale.com/contact, or kind of our Postgres specific email is postgres@planetscale.com. You can email Postgres questions there, or if you want to get access to the early access, you can go there. And I think we will call this stream a day. So thanks everybody for coming. We really appreciate it. And we'll see you in the next one. We'll do one of these again soon.